Can you guys see my screen?
Yes, Rahul.
Perfect. So great. Thank you. So this is the count of number of columns. So it's like a 12 column data set, and it has like 2,500 rows. Okay. Obviously, it is a part of the original data. That's not the entire number of columns which we had, and but these are some of the important columns that I figured out that it would be easier for you to explain to the interviewer. Okay, so if the interviewer asks that what were the important columns, important data variables that were there, so we just start with mentioning that there were personal. Can you guys please go on mute unless you have it out? So yeah, you just have to mention that apart from the personal information that patients used to provide against the patient ID, it was shared with us. Okay, and personal information was related to medical records. Okay, and some of the patients were reluctant to provide the medical records. Some were okay with it. So 70% of the patients were like okay to provide the medical records, and 30% maybe not, but their age information, the area from which they belong to, the bone condition, their blood condition, their lung condition, skin condition, the urological effectiveness condition, and there are some other factors amalgamated all together were affected as well. And then there was like criticality of their patient as well, like whether basically they were having which level of criticality. So it's a categorical variable, level 1, level 2, level 3. And then finally, the predictor. Then finally, our Y variable, basically. The dependent variable was like operation eligibility. So either they are eligible for an operation or not. So yes or no. So this data looks very straightforward in first glance. Okay. But when you think it as a machine learning point of view, you will.
I have one doubt. In all cancers means what is that? Like it is like it has to be a numeric. It has to be an alphabet, no? So
All can. Okay,
yeah, all cancer. Yeah.
Why do you think that it should be?
Because I'm also working on the healthcare domain with the US healthcare, so in Medicaid system. So all cancer means mostly it should be in the name of the disease kind of that column, no? So it should not be a numeric, no, in that J.
Again, again, it is an encrypted data. Okay.
Okay.
And few of the numbers, like they might repeat as well. Okay, in this particular column. Okay, so that's why you are seeing like this. But yeah, excuse me. But yeah, what you're saying is correct. But again, it's an encrypted data, so you won't get all the information that you usually see because like I was requested to get the data, which is pretty much industry related, and the type of information that we get. So that's why.
And
Okay.
original data, how many columns were there?
So there were like, it was for one particular chain of like hospitals, and they control the entire Brazil. Okay, so it was around 2 million something thousand. I don't exactly remember, but the entire data was more than 2 million rows.
Like how many columns, Rahul? It is. I think it is not exact. It should be more.
Yeah, it was more than 45 columns. But basically, I'll show why I have reduced it to this.
Yeah, it is a client sensitive, so
yeah,
you have reduced.
So I cannot share personal information, first of all, and I cannot encrypt that because that will not make sense at all. First thing. Second thing is, if I included them, machine learning's point of view, it didn't make sense because they were not contributing a lot. Okay, there was some external third-party data that I got, but again, I couldn't share it in any public platform or in any institution as well. So that's why I've reduced. So there were some factors. I mean, anyone can complain about me, and obviously I can go to jail. So simply because of these reasons, I cannot share that data. But yeah, again, it has been reduced to 1/3 in terms of column, and but these were the important columns basically, and you will see that even these columns are not following any sort of pattern, even though it looks very straightforward and simple. So that's one thing. And the other thing is like I've reduced it to 2,500 rows because I've tested the data a lot. So it could be, so it is basically one sample of the entire population, okay, that I've taken to share it with you guys. And this sample is good enough to design a machine learning algorithm with good accuracy. I won't say very very good accuracy, but at least a good accuracy. Okay, so that was the agenda behind it. Okay. Okay, so any
So
doubts on that?
Rahul, what these number denotes, like for one patient ID, bone 1733, blood 114, what these numbers are? Like
Okay.
if it is encrypted,
Yes, it
like
is
how we
okay, so it is encrypted data, and it has been linked. I mean, for these information, even I got the data which was encrypted. Okay.
Like you can get it from the data.government, so you can see these values, encrypted values.
Uh, Not every time they will provide information. Okay, because it is again restricted to like information that patients want to share. So, depends on country to country. Depends on the information that you
Like
are.
US healthcare, they released like 1990 to 2000 open data is available in the data.government in US that domain.
This
So
is
no,
not
no,
US. I mean,
no.
and
I'm just saying that. So if you want to, anyone want to test it, they can try and do that sample from that.
do you mean if you'll go to that site and we will put this number, then we will get fetch
Yeah,
some
yeah.
data?
See, there is they will associate some uh, records, encrypted records. So which see in a organization, say in a healthcare domain, I am there, no. So in that they won't give exact thing like what you are like. See, skin type is like so some disease it is allocated with that kind of. They are encrypted with a tabular format. So according to that, you have to prepare the data. So it will be kind of paragraph like so in that you have to associate the disease with a numeric kind of format.
So
okay,
if
so
there,
what?
yeah, if there is different skin level diseases there, so number will denote, okay, this kind of disease, skin disease they have, right? Or the different countries have different number or encryption kind of thing, like.
Guys, if you can allow me, may I
Yeah,
speak?
yeah.
Thank you so much. So, this bone condition and this blood condition, everything that you are seeing right now, the numbers are basically, see, suppose it is they are variable numbers which vary from a particular range. Okay, just like when you go for a blood test. Okay, and then there is a range through which they say that there is a simple range of platelet count, range of hemoglobin and things like that, and what is the exact number or what is the exact range that you fall into. Okay, so all those values, and it's the average of those values, and then it is taken like that. So each and every patient has kind of different value for blood, bone, lung condition. They're all measured under a certain range, okay, through different factors. Okay, when you go for a lung test as well, there are different things that they want to test, and then it's averaged out, okay, for each patient. So that's what it is telling. Okay, first thing. Again, you can see that few of the numbers are varying in 1,000, few of the numbers are varying in 100, and that exactly means that their ranges go from a particular 1,000 values, and there's some of the variables have ranges which go from particular hundreds. Okay, this is other condition, which is like a combination of multiple other tests that were performed on a patient. So this obviously goes into thousands because it's a combination of multiple variables. Okay, so that's how it is. So it is just a range of numbers, and some people can fall into a smaller range, medium level range, or high level range. Okay, and again, it's an encrypted data because they cannot share all the information like hemoglobin count, RCB count, WCB count, things like that. So they can't share related to blood or even the bone marrow condition or lung condition. So that's why it's kind of encrypted. There are multiple ways to encrypt data, which Yash was saying as well. But there is a preference of the data engineering team. There is a preference from the business side as well, and how they want it to be encrypted. So, and this is like one of the ways that I got encrypted data information. So that is there. Again, this data contains like 2,500 rows. So it's one of the sample from the population, which I was talking about. And it was tested and it is good enough to design a machine learning algorithm. Same way, you can get the entire data. There are multiple countries through which and they provide these sort of information, but not exactly at this level. Okay, so this much information you won't get.
Rahul, I have one question here.
Yeah.
So as we are getting encrypted data, then who is responsible to like decrypt those data? Suppose we are training our model on this encrypted data. Then the doctor should understand, right, that he has to again decrypt it, correct, to relate with the original value.
Okay, so the doctor will understand it because doctor will have that context. Okay, because of the GDPR issues, we cannot decrypt it. I mean, most of the companies won't allow you to decrypt it, first of all, because they don't. I mean, if the most of the patients have signed that they don't want to share the information, their personal information or their medical condition outside hospitals. And when they say outside hospital areas, then obviously they mean that their data cannot be shared to analysts or any third-party companies or any company which is hiring analysts or data scientists to analyze their data. So that's why we have to make the meaning out of these numbers and find the pattern if at all they are following any pattern or not. If they are following any pattern, then we can design a machine learning algorithm. That's all. Okay. So that is there. And if it is not following any pattern, then we can like design multiple algorithms for multiple patient IDs. Okay. And there could be a bunch of patient IDs falling under a category, a pattern, which is solved by one machine learning algorithm, or can be multiple other groups which can be solved by other machine learning algorithms. So it depends. Okay. So our work is not to decrypt the data. Our work is to understand the business context of it. And this is the business context of it, that the numbers that we are seeing is a combination of multiple tests that were performed on bone, blood, lungs, skin condition, neurological situations, and obviously their criticality and all cancer as well. So it's all a combination of multiple factors, and it will be, I mean, if you work in healthcare industry, you will get this data in this sort only, because they won't give you each and every information. Because I mean, obviously, if you are a patient, and you would also not want to share this much information about yourself, like what is your RCB count, what is your hemoglobin count, what is your bone marrow condition, and things like that. So that's there. Okay, so when you give the data, and obviously when you give the prediction, the doctors basically don't even have to look at these numbers, because you give the prediction against each and every patient ID. Okay, so they have the patient ID, they have the records. When they enter the patient ID, they first see the level of criticality anyway. And if they see that the model is performing well overall, they've shared the information with management team and doctors. Okay, well, you won't be interacting with doctors anyway. In healthcare industry, you generally interact with a person who is like in charge of multiple hospitals. So there's no doctor involved per se. He must be knowing, or he might be a doctor previously, but he's into management now. So he would be one of the stakeholders. And obviously there would be a project manager involved along with that. So one person who will be in charge of the hospitals, who will be managing the hospitals, and they would want to reduce their basically the work time of doctors. So that's why they want to automate these things. So that's why they choose machine learning field to automate these things. So that like if you have given the prediction against every patient ID, suppose this is the operation prediction of yours, and this is the patient ID, and you've shared this information with your doctors, with basically that person, with management, who's managing that, managing the entire group, and he will share this information with their doctors. Okay, and these countries, they already have a centralized system. So every hospital has the record of each and every patient. They just have to write down their patient ID in their system, and then every record will come up. Then they will check the criticality of that patient, that how critical he or she is, and then if the level is like level 1, level 2, then obviously they won't bother much. They will go for whatever you have said, like if the patient is eligible for operation, yes. If not, then no. If at all the patient is level 3, then obviously the doctor will take out all the record, each and every thing from their system, and then they will try to judge whether patient should be or should not be given the opportunity to get operated. Okay, makes sense?
I have one question, Rahul.
Yeah.
Rahul, as these data is collected, so as you are saying that we have limited the columns to some numbers, correct? So maybe initially you got more than, I think, more columns for this data set.
Yes, I did. Yeah.
Did you perform any feature selection technique or any machine learning technique to reduce the columns, or how did you select the column?
So there was some business context to it. Rupesh, right?
Yes, yes.
Yeah, Rupesh. So there was some business context to it as well. So basically, I didn't want to share information which was related to patient's personal data. So age is still fine, okay, and it's one of the influential factors. But again, apart from age, I don't think like patient condition of like where exactly do they live, like address. Okay, first thing first, and their their history of like whether they are smokers or not, whether they are drinkers, how many cigarettes do they smoke per per day, how many glasses of wine do they drink every day, and things like that, which people don't want to share outside the hospital group, or outside even they don't share with the hospital group as well. Okay, so these information which were not contributing to the factor that we are trying to get the patient operated or not, okay, a lot, I've removed them based on the statistical factors, and based on the factors which were like saying that this close to very personal information that could, you know, that is not necessary as well. So we are not using it in machine learning algorithm as well. But for the sake of, you know, you telling in the interviews, obviously you can say that. Okay, so there were other information that were provided by the patient. So these information, that how many cigarettes do they smoke, how many glasses of wine do they drink every day, this information will not be a central information anyway. You can't get this information out of any system or any, you know, medical history as well. If the patient is willing to provide this information, then and there you will get the information directly from the patient's source, and obviously you can put it in the system again. And that has a consent form which says that whether this information can go beyond the hospital group or not. If not, then they can't share it. So that's the basic GDPR issue with the healthcare data. Okay, and these information I have removed, although I had like 70% of the information of the entire patients, but I've removed them because they were not also contributing. But obviously you can say that these many information were there with my data when you were explaining it to the interviewer. But the most influential factor were age, their bone condition, blood condition, lung condition, skin condition, urological condition. And then they say that what exactly were there. So you say that, suppose give an example of blood, and say that in blood we check for hemoglobin, RBC, WBC count, things like that. It was all a combination of that, which was encrypted data, because each and every information was also not shared with us. We were just analyzing the pattern of that information that was shared. Okay, and then we were trying to do a prediction based on that. Okay, so that's very limited information that you get. But again, you have to get the feel of the how you get data in the industry. So this is the feel that you can get. Okay.
Okay, Rahul. Basically, as per our knowledge and as per data concern, we are limiting the columns.
Yes. Not only that, I have tested it statistically as well. Like they were like because of the lack of the data as well, and because they were not making sense some of the personal information. So it was not making sense statistically as well. So it was basically, when I checked the correlation was very bad as well. So that's why I removed it. That's another fact. Okay.
Correlation for the input variables are very high, so that's why.
Even these, when you'll see that, when we do the correlation in the code, you will see that these variables don't have very high correlation, but they were, the other bits were very lower. I mean, close to zero, negative, minus 2, 3, 4%. So that's why I've removed them as well.
Okay.
Cool. So let's jump to the coding. Okay. So yeah. We understood the data. Any doubts on until the data part that we have explained? Any issues?
No, Rahul.
Great. Perfect. So basically what we are trying to do here is we are doing the classification here, classification of eligibility of patient to go through operation. And this is part 1. In the next lecture, we will do hardcore machine learning algorithms. Here today, we will discuss few EDA concepts, few insights that we want to get out of the data, and then design one simple machine learning algorithm, logistic regression, and get, and without doing any hyperparameter tuning as well, see how well it works, what is the basic accuracy that we are getting into. Okay, so I'll just clear the output so that I can run it one by one and show it to you guys. Okay, first thing first, we'll import all the libraries. Okay, again, there's nothing much to explain. Already I have explained whatever I've written. You can just go through this. There's just one thing that I would say is that logistic regression is a linear model, so which is generating a binary response. So I mean, false will be 0 and true will be 1 in this case, and you can link the response having a binomial distribution as well. Okay. But apart from that, I've discussed everything which is written, so you can just follow, and few information about logistic regression, obviously. So yeah, now this is how the data looks, the first 5 rows. Okay. Shape of the data is 2,502 rows and 12 columns. Okay. To get the description, you get all the information, statistical information that you would want. So if you want to observe each and every column, which is like having a numerical data, then obviously you can do that. Gives you an idea whether the values that we are getting are, I mean, the variables that we have basically has an outlier or not. Okay. And also gives you the median of that data as well. Okay. So yeah, when you say this thing, 2495 is the count, you can see that, and 24099 is the count, 2499, 2494, 2499 again, 2493, and then again 2500. So this gives you one information that there are some missing data as well. Okay. Because the total count that we are seeing in patient ID is 2502, and the shape of the data is also 2502. Again, when you go for age, each and every column, ignore the patient ID, even though it's numerical, because we won't use patient ID as a variable. So this gives me one more information, that we never use an ID column. Okay, never ever as an independent or dependent variable. It is just used as an index value. Okay. So ignoring what is present in the patient ID, we'll go to check age. Okay. So age has a mean of 74.88 and minimum age is -10. So you can simply say that -10 cannot be correct. Okay. So -10 is wrong because age cannot be negative. Then 25th percentile says 70, 75 is 50th percentile. So that means my median is 75 and my mean is 74.88. So it's very close to a normal distribution, but still a bit skewed. Okay, you can say that. And why it is skewed? Because my 75th percentile says age 80, but my maximum value says 220. Okay, so that means it's an outlier, because it can be around, like if it would have been like 100, it would have been fine. And I mean, age, if it is an age 220, does not make sense as well. So something is wrong with this column. Few information are misleading, that we got to know. And then you will compare each and every value, even though you will say that it's encrypted data, it is not making sense. As a data scientist, you have to think analytically, and instead of like getting into business context of each and everything, obviously you should have a business context of the entire project, but even if you don't have business context of each and everything, there's statistical context of each and everything that you can get out of the data, and obviously you can make sense out of it. Okay, and it's important for you to understand the data first, and then only you will be able to explain the data to others. Okay, and then only you will be able to work on the data itself. Okay, so this means that again, following the same concept of age, we can say that in bone as well, the minimum value is 1052, 25th percentile is 3371, and when you can see this is 6198 and this is 6338, so it's close, but I won't say very close, and it's influenced by an outlier, you can see here. So that's why probably it is following a path where like it is rightly, I think, right skewed, basically. That's why the mean and median are not matching. We will go to see, and we will see the normal distribution curve as well. So you'll, if you don't know what is right skewed or what is left skewed, you will get to know that. Obviously, by now, if you have attended all the lectures, you must be knowing that. Okay. So now, when you go for blood, it relatively seems fine, because like from 4,000 it has jumped to 5,000. It should be fine. From 3,700 to 5,000 can or cannot be an outlier. Okay, 2,474 is my median and 2,553 is my mean. So I mean, it's slightly skewed, but everywhere you will see that it is not following a normal distribution curve anyway. Okay, because it's not like mean and median are not overlapping in any case. 3,589, 3,519, again 1,186, and then this is huge gap 784. So that's why we can clearly say that there's a presence of outlier. Okay, so that being said, you just need to use the describe function and actually see what is happening. People usually ignore this, but you can actually see what is happening in your data and get a lot of information from this particular bit only. Okay, now when you see when you want to find duplicates, so probably you can see that first check that you can do is there any duplicate, exact duplicate, exactly a replica of rows which are present in your data or not. So we can say that we can find it by the duplicated function in the Python. Okay, just have to the entire data is inside a object called patients, or variable if you prefer, patients. Okay, and when you want to find out the duplicate, you just have to write patients.duplicated. It's a callable function, and when you like get a print out of it, it will give you the 2 rows basically in this data which are duplicate. So the next step would be to replace, to remove those duplicates. So just you have to write drop underscore duplicates and in places is equal to true to actually make it happen. Now,
one question: how many
yeah,
duplicate rows are there? It is showing that we have duplicate data, but how many rows?
2 rows you can see here, right? The number 86 and the number 386. You can take a sum of it as well, but there are 2 rows which are duplicate. So I've just removed these 2.
Duplicate row count is 2 for each row.
No. These 2 rows are entirely duplicate in the data. So exactly this is available somewhere else. Exactly this is available somewhere else.
One time repeating, correct?
Yeah, one time repeating. Yeah. Okay, so these 2 are duplicate rows, exactly duplicate rows in the data. So we need to remove them. So we have just dropped those duplicate rows, and then we go ahead and check the null values. Okay, so now that we have removed the 2 rows to duplicate, we are left with 2,500 rows. Okay, and 2,500 is the final count of all the patient ID. And when you compare it with the other variables, 2494, 2497, 2497, 2492, and again, you can go until other, you can see that there are some missing values present in the data. Okay. Obviously, you can check the data type as well. So I would say get a feel of data type. So patient ID, integers, fine. Age, float, 64. I mean, you can live with that. It's fine. If you want to change it to integer, you can change it. Region, again, object should be fine because we want it as a string data. Again, bone, blood, lung, these all are float 64 and should be float 64. Criticality is object, which is fine, and operation like yes or no is object and should be fine. Okay. I have also, I mean, in this project class link that I've shared, I'll share this today's lecture information as well in the same link. Okay. If you guys want to, get information like how to change the data type, you can just download this Python file. Okay. Retail data cleaning and EDA. We have just, I mean, those who were not present yesterday, for them, you can see each and every information that how to handle these sort of problems where we are like handling, changing the data type of a particular column. You might be knowing as well. If you don't know, then just in case. And in this data, this problem is not faced, so we won't be doing any data type change basically. But yeah, I mean, if you want to, just a matter of like, if you want, because age would be an integer count. It won't be like a particular person is 62 years and 34 months or something like that, 12 at 8 months old. I mean, it can be the case, but that information is not with us. So you can change this to integer type. You just have to use as type to change it. That being said, we want to get the mean. I mean, we want to replace all the null values with mean. So we've just replaced it and we want to get the information. So now everything is replaced by a mean value. Why I've done it and what exactly you can do it as basically your homework. Okay. This is a shortcut. Okay. So basically we have 2,500 rows. So 5, 6, even 10 rows, up to 10 rows also we are, if we are changing and directly with mean value, it won't matter a lot. Okay. But what you as a data scientist should do, okay, if you are very much, inclined towards getting the perfection in the accuracy, what you should do is basically you should do outlier testing and replace the null values of each column accordingly. Now, why I'm saying accordingly, you should be having an idea that what exactly happens when you get an outlier, okay, in the data, and whether you replace it with mean or median or maybe mode. Okay. So you need to do it. Okay. For now, if you want to replace it with in the entire data, just replace it with mean. If you want how it is done on each and every column, okay, you can again go to this EDA Python file and then check a couple of lines of code.
Like we can give the if condition if this value is equal to int 64. So in that we can give a condition and we can replace it, no, column wise, in the row wise.
I mean, you don't have to do that. I mean, you can obviously get it in the entire data frame. So separately, separately take them out in a different data frame. That would be more, easier way to do it. Okay. And there are some missing values in each and every variable, which and the missing values basically are present in numeric data type only. So float 64, basically you can see that they are present in those. So, and only in numeric data type column only you will have to, like, you can replace it with mean or median, but that's not the point. The point here is basically have to test the outliers. If there is a presence of outliers, then basically replacing the null values with mean is not the viable solution. Okay, so you have to check the outliers. Okay, and If it's a small number, still it's fine. But again, if it is like 10%, 20% out null values that are present, you'll have to impute sensibly. So that's why this is a homework for you guys to check the outliers first and then do an imputation on each and every column accordingly. Okay.
Rahul, I have one question here.
Yeah.
Like, can we use the KNN imputer here, as you said yesterday, if the input variables are dependent on each other? So here, I think independent variables are dependent, correct?
Independent variables are dependent on each other. That's your assumption. You have to test it first. Okay, Rupesh,
Okay.
whether they are dependent or not. Okay, if they are not, then obviously KNN won't work. But I would say you can give it a try because it depends on the data. I haven't tried imputation using KNN because yesterday also I said the same thing. Again, if it is trying to find out, data points which are very close to each other, and then it's trying to find out the median value, it will be very close to the median or mean value of that particular column itself. So instead of designing an entire algorithm just to do imputation, we can just replace it with a median or mean value. That would save a lot of time.
Okay. And we can also do one thing, like we can uh, impute the values on the basis of mean and median by checking the outliers, and if their distribution is not changing a lot, we can draw the KD for each column. If
Yes,
their
absolutely.
distribution previously and now it is not changing, then we will use the same process, as data is missing here is approx less than 5%, and if they are
Yes,
also missing completely at random, then this thing can also work.
yes, absolutely. You're absolutely correct. Yeah.
Okay.
Okay. Yeah. So yeah, when we were getting so your homework is to do outliers testing.
Like
I will.
I have added the piece of code like that. We can do it now.
Yeah, it's just below. You can do it. And obviously I haven't what I haven't done is I haven't done it for each and every column. Okay, even that piece of code is there in this particular file. You can get it from there. But again, I would want you to do some Google search and try on your own first. First, do the outlier check. It's already there. Okay, before replacing these values altogether. Okay, and now that I've replaced, I'll get some different value. But again, and see if you can finally improve the accuracy by even 1%. That would be great as well. Okay, so now that we have replaced those null values, there would be presence of outliers anyway. Okay, so you can see -10, 220 is there in age, in bone also it's there. But again, the mean has shifted, like mean has changed. So if you can compare the mean of, say, bone 6198, okay, sorry, median 6198 and 6338 in mean, when after replacing those null values, it has changed slightly. So 6338 has become 6341, and 6198 something was the median, so 6210. So that has shifted a lot, a bit as well. So this gives you an idea that yeah, it can work in most of the cases, but it cannot work in few cases. And in those cases, basically, which are influenced by outliers, okay, again, that could be risky to do an imputation with mean, because if it is a large number, suppose I'm replacing a mean value, a null value, with the mean of the age column, which is influenced by one of the values, which is 220. Okay, it can be a small effect, because, and that too only because like it has one value which is 220, right? And there are 2500 rows, so on an average it is contributing to like very small number for the entire 2500 rows, because we are taking an average. Okay, but here in this case, or maybe not even that, in case of urological, like from 998, so it is going to 11019. Okay, so that particular number is highly influential. So if I replace a null value with a mean of urological column, okay, that could be misleading to my machine learning algorithm. Do you understand why? If you have any doubts, just cross question me. I'll try to clarify as much as possible.
Can you repeat the question?
Yep. So Rupesh, what I'm trying to ask is, And it's a lot of visualization that you have to do. Okay. So imagine this is a column. Okay. And obviously mean, if you try to calculate a mean of that column, and if that column has a very large outlier, okay, even though the number of rows are like 2500 or something like that, which is here in this case, that large outlier will be an influential factor in calculating the mean, right? And if that outlier, or maybe multiple outliers, are present in a column, and they are contributing towards the calculation of mean, and that column has some null values, and we are replacing those null values with mean, will that be a viable solution? Will that be a leading or misleading information that we are giving to a machine learning model?
Yes, it will not be the correct way to replace those null values.
Exactly. So what we have done here is basically we have just replaced the entire null values of the entire patient data set with mean, which can be misleading, not in all the cases, but in some cases. And one of the case would be urological, I would say. Okay. So here in urological, there are 3 rows which are missing. Okay. Even if there are 30 rows that are missing, it doesn't matter. Okay. Since there's a presence of outlier, and that too because of a very large number, because like you can see, the minimum value is 303 and 75th percentile is 998, but the maximum value is going to 11,019, which is like a huge number. Okay. So it should have ended by 1500 or something, but it is going up to 11,000. So that is an influential factor. And maybe there are multiple outliers present that we can check in the description box itself and get to know that, yeah, if we are to replace a null value, even if they're like 3 values, 3 rows or 30 rows, then mean cannot be a viable solution. That's why this homework is given to you, to do an outlier testing and then replace the null values of each column accordingly. What you will observe here is
I
there
have
will
one doubt, Rahul. Outlier
yeah,
testing means you're talking about IQR only, no? IQR testing.
some support either via IQR, or if you want to just check, you can just do a testing using basically box plot. That also is fine.
Okay.
My problem with right now is not to replace those outliers. Okay, my problem right now is to replace those null values, right? So first thing first, we'll solve the null values problem. Okay, and these are the interview questions that basically interviewers ask, and when you give them the straightforward answer, they understand that you don't have a lot of experience, or you're lacking any sort of experience. So even if you go to right now, chat gpt is very famous. So even if you just log into chat gpt and ask like what is the best way to replace null values, before handling outliers or after handling outliers, look into it, what answer it gives. Okay, and I'll share the solution, to you as well. And I have what ChatGPT or any other website will tell you to do is basically what I've faced in the years over the line. And basically what happens is, when there are some advantages and disadvantages to replacing these outliers. So replacing these null values. So when you do replacement of null values before an outlier check, okay, and if there is a presence of outlier, then obviously it can give you a misleading information. But try it once, okay, just like I have done, okay, and then you handle those outliers, okay. You can see those outliers, and accordingly you can do the imputation. So maybe if there is a presence of outlier, then obviously you replace it with median. If there's no presence of outlier, then replace it with mean. Okay, that's another thing. If you have done that before handling outliers,
Can you repeat one more time, Rahul? Like previous step, what you're discussing. So
okay, yeah. So if you have handled the outliers, okay, handle the outliers, when I'm saying, then I'm not saying that you have replaced these outliers with any of the values. Okay, you're just checking that there's a presence of outlier. Just in this case, yeah, it's better to show you practically. So in age column, as you can see, -10, there's just -10 which we are getting, and there's 220 that we are getting. You can see visualize from the box plot as well. So there are presence of outliers in age column. Okay, in bone, blood, lung, skin, it's fine. Urological has a lot of outliers, okay, which are basically making it right skewed. Why I'm saying right skewed? Because it is like going into the higher end. Okay. Heart, other is fine. So when I'm saying I'm replacing those null values with in bone with mean, it should be fine. Blood, fine. Lung, fine. Heart, other, and skin is fine. But in cases where even in this case, like age, it should be fine because it's not even 220 and minus 10 and 1020 numbers are not contributing when you do the average. They are not contributing a lot in the age column because they are 2500 rows, right? But in this case, urological, there are a lot of outliers that are present, and it's not at all correct to replace it with this value. Okay, replace the null values with the average of this particular value, because your normal distribution curves here ends here, and your median right now is here. Okay, your objective should be to get the entire data into a normal distribution inside the box
Uh,
plot. Okay?
Rahul, when we have to use a mean or when we have to use median. So if
Yeah.
object time means we can use mode, but what
Mhm.
scenario when we can use mean or median?
So you can see here, right? Like in this case, you can use mean. In this case, you can use mean, even though the mean and median are in these cases are not falling in the same, position. Basically, there could be slightly uh, difference. They could be slightly different from each other, but then the most if there is no outlier present in the data, then the most perfect way to replace a null value would be with a mean value, right? Because it's statistical average, it's a calculated average, while median is a positional average. Okay, so if nothing is influencing your mean, not a high number or not a very extreme number, then obviously you can replace it with mean. When there is a presence of an outlier, okay, then obviously you have to replace it with a median value. Okay, and in this case, mean and median, it won't matter a lot, honestly, because there are not a lot of outliers, and even the outliers are not very high. And considering like 220 divided by 2500, it's a very small contribution anyway. But in this case, obviously you'll have to take care, and that's why the homework for you guys is to do these outlier check, draw a box plot, okay, and then do these outlier check, and then try to replace it each and every column. So you can take the age and other as well, age and urological as well out of the data, and then you can do the imputation accordingly. So any doubts in this point, until this point? Obviously it should have been covered in this class.
If we have that, if if we face outlier, then we need to apply with median.
Yes, in most of the cases it's true. But again, if your extreme value that your box plot is saying, like in age case, if it is not very influential, then obviously you can replace it with either mean or median also. That should be fine.
Yeah, like median also deals with the middle point. M- uh, on mean is deals with average. Both are little bit slightly correlated. No, Rahul.
I'll tell you something. There you can see the mean is 1185, right? And your median is 785 in this. What do you think? Why it is happening? So there's a difference of 400 points, right? But here
Yeah.
in this skin is 3588 for, and the median is 3588 and the mean is 3522. Again, you can see 2534, 2483. Even when I'm talking about age, it's very close, even though there's a presence of outliers. So age has 74.88, and that's your mean, and your median is 75, right? Which is very close, because this 220 number, it's not influencing a lot. Okay, because the presence of high number of rows as compared to this particular value. Okay, so that's my point. If there are a lot of outliers present, then obviously your median and mean will only tell that, yeah, it's there are a lot of outliers present. So, and when mean will be greater than median, obviously it is right skewed. When mean would be less than median, obviously it will be left skewed. Okay, so the differences of 400 points, which we haven't seen in the data anywhere else. Okay, in every other column you can see that there's a difference of 100 max. Okay, 6210, 6341, 1 point, 100 point again, 100 point again, no, 60 point again. But here it's a difference of 400 points. So imagine a scenario where it could have been like, for a patient, the urological condition would have been like 500 points, 600 points, okay, 700 points. And we are replacing that with 1185. That would be wrong. That would be misleading, right? Even though their information is not with us, a particular patient has this urological column, this urological column's one particular row, which is missing. If we replace it with 785, it's still fine, okay, because it could have been like 400, 500, 600, 700. Okay, we are doing that. But if we replace it with 1185, that is very, very much misleading, right? Do you understand what I'm saying?
Yeah, I got it.
So that's the whole point of this exercise, that you have to understand that how many outliers are present, okay, and are those outliers influential? If they are, then obviously you don't have to replace it with mean, okay, because it's a statistical average and it will consider all the data points all together to take out an average, and then you can do the imputation, which could be correct in case of age, because as you can see, even if you replace it with 75 or 74.88, it would hardly matter, okay. But in this case, if you replace 785 with 1185, it will matter, okay. So that's the entire thing. That's the entire point. Now, if you want to get a normal distribution curve, it is, I'll just show it how it works. So it's basically designed to show you the lower percentile, upper percentile value, IQR value, okay. And everything that you are seeing here is basically tells you an entire story. It tells you the story about a urological column in your data, okay. So why urological column? Because it is having a lot of outliers, and we need to study it a lot. I mean, we need to study this particular column altogether to see what exactly is happening. So you can see that it's following a normal distribution curve, okay, trying to at least. And there's a mean and median, okay. So if you go to the legend, you can see that the mean is slightly shifting to the right hand side. So, and median is in this green line, okay, you can see. And exactly the same way you can upgrade here is,
I think this is a right skew, no? Like,
yes, this is right skewed. Yeah, you're correct. So you can make it out from here as well. Like this is also right, and this is right. This would be a right skewed because on the upper half there are a lot of outliers present. And if like your median, if your mean is greater than your median, then it will be right skewed. If your mean is smaller than your median, then it will be left skewed. Okay, that is also a concept. So yeah, again, what you see from box plot, exactly 25th and 75th percentile, it is there. Okay, and obviously your mean is shifting towards the right hand side, so there would be presence of outliers. Here you can see these outliers also are following some sort of pattern. Okay, so when you are trying to design a machine learning algorithm, okay, what you can do here is basically you can take instead of replace, we will do right now, we will do the replacement of these outliers with a particular value, okay, mean or median, we'll see. But what you can do here is you can take these outliers off, okay, and you can see that they are following some sort of pattern, and do a separate analysis of these outliers rather than making them inside this particular graph, this particular normal distribution curve. You can take them out and do a separate analysis, as we were discussing yesterday as well. If you were present, we were saying that if a group of outliers are following any sort of pattern, okay, and even if you have a hint of doubt that they might follow some sort of pattern, you take them out and do a separate analysis and see if you can design a separate machine learning algorithm or tweak your existing machine learning algorithm to find a way to get better prediction. Okay, so if your 80% of the data, say, is following under a particular range, it's fine. You can take them all together with other variables, and that should be fine. But the 20% of the data which you think is extreme data can or cannot be misleading. So you cannot always handle outlier just on the basis of saying that since it's an outlier, we need to handle it. We need to replace it with mean or median or whatever. No, you cannot do that. you have to check in a normal distribution curve. Right now, with a box plot, you're not able to figure out whether it's following a pattern or not, right? Because even in this case, it is following a straight line. And you're saying that, yeah, obviously it is an outlier. 3 data points here, 1 data point over here, multiple data points over here. But here, in a normal distribution curve, you can see that it is following a pattern, okay? Most of the data is coming inside one distribution curve. But again, there's another curve that it is following. It's again following some sort of pattern, okay? So you need to take them out and do a separate analysis. Right now, first thing first, today's lecture, we won't do that, but I'm telling you that this is something which you can do to improve the prediction, okay? Again, if you want to test some other data, so obviously age is the other variable which is having outliers. So it's always a good thing to do these testings on a box plot, okay? Once you see that there is a presence of outliers, just visually, you can further go and draw a normal distribution curve to do this analysis. Again, for those who were attending yesterday's lecture, this normal distribution curve is a part of, data cleaning and EDA as well. But I didn't show it yesterday because either it would have come to the project class anyway, or like you can draw a normal distribution curve yourself as well. But when I was talking yesterday that you can find a pattern in the outliers, in yesterday's data, there was no pattern in the outlier. That's why I didn't show that normal distribution curve. And basically in today, in urological column, there's a pattern in the outlier which you can handle separately. So when we say handling the outliers, it's not always replacing the outliers. Sometimes you can take them out and handle them all together separately to analyze the pattern in that particular data as well. So that's a separate data set, considering the fact that they are following a pattern. Okay.
Rahul, one question I have.
Yeah.
Like if our outlier data is more than 20%, then we are going to handle it separately.
Depends, Rupesh. Not necessarily that it should be more than 20% or more than 10%. If it is following a pattern, then you take them out and do the separate analysis. When I'm saying separate analysis, doesn't always say that you will be designing a machine learning algorithm. You can design a machine learning algorithm if, say, suppose in 2005, this is 2,500 rows. If there are 2 million rows and they're like, if the number of outliers are like 20,000 rows, then obviously you can design a machine learning algorithm. If at all the data says that there are only 20 outliers present, you can simply design a formula, right? Mathematical formula, which can give the prediction, right? For those 20 rows. There's no need to design a machine learning algorithm for 20 rows, right?
So those 20 rows will be act as test data.
Those 20 rows will be a post-processed data. So you can say that for these 20 rows, these are outliers, okay? And for them, we are just handling it manually. And then you will attach your prediction that you have handled manually with the prediction that you have got from machine learning algorithm for the
Rahul, I have attached the formula. So is it working? It will work, no? Maximum for all the columns.
Yes, it will work. I mean, are you talking about something which you have done in your project or something, or?
Yeah, I already done this.
Yeah. So you
Rahul,
can do.
Are we going to handle this part in our class?
Not today, Rupesh. Not today. Okay. Okay. So that being said, we again go to age column. You can see that there's just one data point 220, and there are some other values, and there are three data points which are outliers, and there's one data point which is the outlier in age column. So it doesn't matter whether it's following any pattern or not. And even if it is following for these three, we won't bother much, because again, if you replace it with any average value, mean or median, it won't matter because there's only 3-4 rows anyway. Okay. Now what we are doing is replacing the outliers with median values. Okay. What exactly is happening here is like we are restricting the data with the age less than 85, and if at all the age is more than 85, as you can see from here, it's almost 85 kind of. Or if you want, you can like take the range of or minimum to maximum value, or 25th to 75 percentile value, whatever suits you well, or you can calculate the interquartile range and then you can decide it. So if you do the interquartile range and then you do the calculation also, then also it's fine. Okay. But here, the interquartile range is also calculated, and you can just take this low and up value, get it printed, and find out the value. What I've done is I've just taken from the visual numbers. So I felt that 85 should be a particular value, after which whatever lies beyond 85 can be replaced with median. Whatever lies below, say 60, can be taken as median. So whatever values that will be present here can be replaced with median. Whatever values that will be present after 85 can be replaced with median as well. So when you run this code, basically it will be replaced with the median value of that particular age. And again, in this case, when the value is less than 60, okay, again it will be replaced with median. Okay. For the urological condition, you can say that around 1380 is 1400 or 1380. I've replaced it with 1380. You can just check the interquartile range. Again, it's a homework for you, because this we have discussed in the EDA project class. You can just go back and check. And you can just take this value from here as well, but that's up to you. And these homeworks will make you work a little as well. Otherwise, you just gaze through this code and you won't do anything. So that's the problem. Yeah, find out the IQR and low and upper quartile value to decide the outlier replacement criteria. Okay. So that's your homework. Okay. So what I've done is from this visual, I have decided that this black line says that it should be around 1400 or something. So I've taken 1380, and this should be and the next one, the previous one, says that there are no outlier present anyway in the left hand corner, so we don't need to handle them. Okay, but they are present here, so we need to handle them. So right now we've just handled it. Anything which is going beyond 1380 is replaced by median value. Okay.
Rahul, I have one question.
Yep.
This is also known as end of distribution method to replace the values, correct?
Yes.
So basically we are taking the mean plus 3 sigma and mean minus 3 sigma.
Yes.
Like that?
Yes.
Okay.
Rupesh, can you elaborate what you're talking so that
What you are saying is not entirely correct, Rupesh, actually.
Rahul, but in the
can
end of
be,
distribution, we'll be replacing with the max value, right?
why would
Here
you
we are just replacing with the median one. At the end of distribution, I'm talking about.
these distribution, this thing?
Yes. In the end
Right
of
now,
distribution.
right now, whatever value is coming from this black line to this particular point, everything is replaced by median. Okay.
Yes, but in end of distribution, we'll be replacing with the max value. I am saying.
No, mean plus 3 sigma. That is the value.
Rupesh, what is your question? So actually we didn't get you.
No, these are the some techniques to handle the missing values. Like we can replace it with mean or median. We can
Simple
use
imputer, that concept you're talking of, kind of.
yeah, simple imputer is a scalar method.
Yeah.
And there is some other method like we can use end of distribution.
Okay, can you type that in that chat box so that everyone can?
And Rupesh, one thing that I want to mention, if there are a lot of outliers present, okay, mean plus 3 sigma method is also not a very correct way to do imputation as well. Okay.
I think in that way we can use IQ or Rahul.
Yes, and that's what I'm using. So yeah, I'm calculating this number is coming from IQ also, and that's your homework to check if that number is close, or either you can do a more refinement in this particular bit. So
because our data is skewed here, that's why we are using the IQ method, which is the best method for this purpose.
Exactly my point. Okay, but yeah, I mean, feel free to share that information with others, because if they don't know, they should know. But again, this method is also susceptible to outliers, so you don't have to use it, because again, mean, it is using mean, and mean again is influenced by outliers, so you cannot use it, anything which is influenced by the outliers to do the replacement. Okay, but yeah, please go ahead and share the information with them.
Yeah.
Okay, now again, and now I am, once I've prepared this data by replacing the outliers with median values, right? What I need to do is I need to check that what are the values, what are the variables which are basically important, and so when I'm saying important, there should be numerical values, and is there a presence of outlier after replacing them or not? Okay. So now that we have replaced it, we need to check whether they are having any outliers. So you can see age is fine, everything else was already fine, urological is also fine. Okay, so this magic happened because we have replaced it with an IQR value that we have calculated, or we have visualized that it could be like 1380, 1400 or something like that. That's if it is a precise value or not, or there could be more changes that we can do. That's your work to do. Okay, if you combine information from here, and if you combine what we have done in the previous class, obviously you can do, and that will give you an opportunity to learn whatever we have learned this entire weekend, and you have the entire week to do it, so make sure you do it as well, and feel free to have to ask any questions if you have. Now again, if you want to just check what is happening in the distribution curve of urological, you can do it for age as well. I'm doing it for urological, but you can see that it has been replaced, so it should be fine. Even the urological are all the data which were like outliers have been replaced by median values. It should be fine. But let's check it in a normal distribution curve, how it works. So as you can see, uh, from here, like in the left hand side, the data was not very not skewed as well, so it was right skewed. You can see that the mean has shifted towards median. Okay, it is very close to the median now, so you can say that it's almost a normal distribution curve. But here you can see that there are some data which are present, okay, which is going beyond this outlier range high line. Okay, can or cannot be misleading. I mean, if it is like 1 or 2 data points, we won't bother. If you want it more perfect, then you have to figure out a way, and that underlies with this question itself. So once you solve it, you will get to know it. Okay. Now what exactly is happening here is the mean has shifted, and it is almost trying to overlap with median, so that means the skewness has reduced. Okay, but there's just one problem. Okay, when you compare this normal distribution curve, okay, right now, okay, and when you compare it with this normal distribution curve right now, you can see that a lot of data which was contributing to the right skewed value of this curve has now come into very central part of the data, which is uh, basically saying that we are trying to manipulate the data in such a way that it should be central as possible, which should be our aim. Okay, because if the data is following a normal distribution curve, we are basically making it very linear for any normal of any machine learning algorithm to give me prediction. I'm sure you guys know that. What exactly is happening here is when you see the variance of the data here, but just by the looks of it, you can calculate the variance altogether if you want. But when you see the variance of this data, okay, it has increased significantly a lot. Okay, when you compare it with this particular graph here, the variance of the data is too much. Okay, and that also says, as a data scientist, you should understand that when I'm doing a lot of you know data manipulation on these outliers, that means that I'm misleading my machine learning algorithm with a set of data which should not be shown to my machine learning algorithm, basically. Okay, so that's why instead of like replacing those value with median, the best possible solution could be something else. It can be possible that this is the best solution. Okay.
Rahul, sorry, can you please repeat the last sentence once?
Yes, of course. So this the variance you're talking about the variance, right? You want to understand what I was
Yes,
stating.
yes.
So as you can see, the variance of the data over here, it has significantly increased as compared to this particular graph, right?
Correct.
And when you say that the variance of the data has increased because of your data manipulation, which is not originally present in the data, that means you are imputing the data with such a number which is making it very much central, and that should be your aim altogether, but it should not increase the variance significantly high. Okay. And when it is increasing the variance significantly high, that means it is misleading your machine learning algorithm. It is not asking your machine learning algorithm to learn those things which it should learn. So, and which in turn means that if at all the set of outliers are following a pattern, okay, then a machine learning algorithm should learn from that pattern as well. Okay. You should not change that pattern so that your machine learning algorithm learns the pattern that you want it to learn. It should learn the pattern that data contains in itself. Okay, you understand my point. You
Yes,
should
Rahul.
change the originality of the data, and here by increasing the variance of the data, we are trying to change the originality of the data. And what exactly it means to the outcome is, when there would be a presence of outlier, okay, present in the data, okay, and suppose that outlier is present for a particular patient for which you want to get the prediction, in that case it will be a wrong prediction that your machine learning model will make. Okay, because your previous historical data was showing some pattern to your machine learning algorithm. You have changed that pattern, and you are expecting that your machine learning algorithm will somehow learn that pattern and give you a prediction towards that pattern, that pattern lies in the outlier data. Okay, but you have made your machine learning model not robust enough to do that. Okay, and that's why right now, for understanding purposes, this imputation is still fine. But and there could be a case where you are, yeah, I mean, if you are doing the pattern analysis and you don't find that this pattern analysis is link and pointing me towards a machine learning algorithm, and still fine, you can do a separate analysis, you can do manual calculation, and then of course merge the result with your machine learning algorithm results. So it could be 50 rows and you're doing manual calculation for 50 rows, and then you include the result of 2450 rows with the that is coming from machine learning algorithm. But in this case, at least you're not misleading a model. At least in this case, if the data which is outlier, which is present in future, which comes in future, you can simply flag them out and take it out, because your machine learning algorithm is not prepared. Once you have enough data collected to do a pattern analysis and train your machine learning model uh, towards it, then obviously you can stop doing that manual work and infuse that data altogether itself. It's not the perfect solution, it's not the correct solution. Okay, and these are the things that an interviewer tries to ask, want to reach there, the point where we have reached as of now. But what you guys, when you give the answer, you basically struggle in these areas itself, and the interviewer does not reach to this point basically. Okay, so you have to describe it in certain manner, the way I have described, step by step, so that it reaches this to the interviewer reaches this point. Okay, if at all that interviewer is very much into statistics, or a statistician or a PhD, he definitely would want to reach to this point and want to get to the basics of this outlier concept, that why we are seeing this, what is happening when we are doing the imputation, what exactly is increasing, what exactly is decreasing, how this mean to median shift is happening, what is happening with the skewness of the data when you are doing this. And when you understand this concept, each and every question's answer will come into your mind and you will be able to solve it. And then that level of satisfaction will reach to your heart and interviewer's mind as well, that yeah, this guy knows and he will be a good fit for my company. Okay, so that's how you should answer.
So Rahul, here variance is getting increased, so we should have some other approach in our mind that we will test.
Yes, exactly. Right now we won't discuss it. Next week we might, but obviously right now we will see that how it works. So basically, I know I have done something wrong. Okay, but let's see. Let's set a benchmark even with this wrong approach. Okay.
Correct.
So now, if we describe the data, obviously you can see that. I mean, I'll just discuss about your logical. So the mean is 723 and the median is 729. So it's very close, and 723 and 729. So you've done a decent job. But again, when you understand the very basics of it, understand the variance, understand how data is working over here, you can say that obviously there is something wrong with the imputation, which can or cannot be a very influential factor in my data. Okay. So 723, 729. Now it is very much in line towards the mean and median comparison of the other variables. And it's rightly so. Okay. Because we have replaced it with median value. Now, if you want to get the information, there are no null values and everything, the data type. If you want again to change the data type of age to from float to integer, feel free to do that. Okay. Now, when you go ahead and at the very beginning, you can see that this particular value, criticality and operation, they are categorical variables. Obviously, there are 3 levels of criticality and 2 values in operation, yes or no. So in order to give you a machine learning algorithm an idea, you have to mention that, you do need to do label encoding. If you don't know what is label encoder or label encoding, it just replaces your categorical variables into numbers. So in case of level 1, level 2, level 3, it will be replaced by 0, 1, 2. And in case of true and false or yes or no, it will be replaced by 0 and 1. Okay.
So
So
target we can use label encoding. For independent variable we can use one hot encoding. No. Rahul?
You can use one hot encoding, but it's just there are 3 values in it, so it's 3 levels of criticality, so it won't matter. Okay, so even if I do 1, 2, 3, then also it won't matter. 0, 1, 2, then also it won't matter. It will always consider the mode of that particular variable. Okay.
For the input variable, one point to add, for the input variable, if we have some order in our input columns, then the ordinal encoding will work. If you don't have any order, then one hot encoding will work.
One hot encoding will, you can do one hot encoding as well. Feel free to do that. What happens here is
Don't have any order, yeah.
we don't have any order, first thing. And the other thing is, if it is considering 1 and 2 over here, it's fine. If it is considering 3 and the 3 is very large in number, okay, then in that case, that could be misleading as well. So it depends when you do one hot encoding, when you do label encoding. Okay, it's not a golden rule to do one hot encoding or label encoding independent or independent variables. Okay, it depends.
But Rahul, on the label encoding we do for our target column, right?
Label encoding you always do for your target column. Okay, if at all your label encoder, if at all it's a binary target variable. Okay, if it is not a binary, if it's a multinomial, then also in that case you can avoid doing label encoding and you can do one hot encoding as well. Okay, so again, one hot encoding obviously is more satisfactory because you do according to your will. Okay, so if you want, you can do it. But here in this case, we can use label encoding because there are only 3 variables over here, 3 categories over here in the criticality column, and 2 categories in the dependent column. Okay, so 0 or 1, either it will figure out that obviously it should be labeled 0 or 1 basically.
But I have one doubt. If we do the one hot encoding in the target column, then how it will create 3 different target columns or 3 classes?
No, at the time you can use pd.getDummies. So instead of if you are not applying the label encoding, you can use pd.getDummies. So
PD get dummies is for the that part one hot encoding.
No, like basically what is that principal rule is like where and all zeros are there, it will uh, give 0, rest of the column it will give 1, like that, for understanding the mathematical behind that.
No,
So
that is okay. That you are talking about input variables, but for the output variables, how it will work one hot encoding.
So for output variable, what will happen, Rupesh, is like it will. So one hot encoding just will you will be able to decide what label you want to put. Okay, one hot encoding you can just decide the label that you want to put. If you want to put a 0 as true, false as 1, you can do that. If you want to put false as 1, 0 as true, true as 1, false as 0, you can do that. Okay, it doesn't matter. It won't. One hot encoding won't make your binomial variable into multinomial, if that's your doubt is. Okay. Okay. So that being said, you can do label encoding. If you want, you can do one hot encoding as well. You can simply get a code if you're not satisfied the labeling within label encoding. That's up to you. Okay. Okay. So again, if you check the patient info, everything is still fine. Now this basically has what here is. Yep. Okay. So what has happened?
check, no? Multicollinearity check. So yeah.
So you want to do multicollinearity check?
Yeah, in between the independent variables. So which is highly correlated with each other variable.
Yeah, we will do that. Don't worry.
Okay.
Okay. So yeah, again, so 2500 rows, a non-null and integer. It has changed from object to integer type. Okay, now that we have done a label encoding, so that's what we are seeing here. Now, if you want to see the count plot to check the balance of the data, so it's exactly very much balanced. So 0 and 1, basically it's very much coming out to be all together. So it's a balanced data set. So we don't have to handle the imbalance in the data as well. So that's fine. But if it's there, then it depends. Like if it is like 60-40%, then obviously you can add some more rows to get the imbalance. If at all the imbalance is pretty high, then obviously you can uh, go for a forest based or tree based algorithm. Try with decision tree first. If it works, probably it won't work, but yeah, try it with decision tree just to save the cost, and then try for random forest. That will definitely work, because random forest, obviously, but the working principle of random forest says that it takes the random values from the large data set and puts into its bags, and then tries to give it to their decision trees and takes out the vote from them and then do the average of it. So basically what happens is like each and every time it can take some contribution from 0, and each and every time it can take some contribution from 1, and there's a possibility that it is learning from the same data, and there's a possibility that it is taking new data from one particular label and the other particular label as well. Okay, so that reduces the misleading information that your imbalanced data set can give. Okay. But again, if you want to balance it, suppose it's 60-40 or 65-35% difference, then obviously 10 to 15% you can balance it by adding some more rows into the data. But if it's a large imbalance, then obviously instead of like doing it manually, you should go for a machine learning approach. Okay, so correlation check. If you want to check the multicollinearity, there is another way to do it as well, but you can just simply judge your correlation numbers and see if there is multicollinearity in the data itself or not. Here, what you can see, I mean, it's the same thing. Either if you're comfortable with this, then you can do that, or if you're comfortable with a grid plot, basically, then obviously you can do check this one. Okay, so as expected, our data is not very much, correlated. So you can see that there's minus 0.029, minus 0.015, minus 0.038, minus 0.1, minus 0.01, and like positives, but still 0.04, like not even 2, 3, 4% maximum, not even 5% correlated. Only age is a bit correlated, like 28%, and criticality is 38% correlated to your operation column. Okay. Again, when you talk about the multicollinearity, if you want to check, there's no variable. Suppose I take criticality. Again, criticality will be highly correlated with itself, obviously. But when you want to check, there's nothing, no variable which is falling under green zone, or even falling under a dark orange zone, which is which is which says that it should be even 50% or 60% correlated. So you can see, if you want to check separately, you can check as well. But from this numbers, these colors only, you can see that there is no multicollinearity which is present here. Okay. And basically, they are not very highly correlated towards the dependent variable itself. So it's not contributing towards any, these independent variables are not very highly contributive towards the dependent variable. And that's the reality of a practical data and industry based data. Okay. It won't be like Kaggle data. It won't be easy and cozy. Okay. There could be problems related as a data analyst, which we have discussed. I think if you have attended yesterday's lecture, 70 to 80% problems that a data set has, we have covered them. Okay. While cleaning it, this is relatively a clean data, but again, from a machine learning's perspective, this particular data is not at all good. I mean, it's not good enough, and it will be very difficult for your machine learning algorithm to find out a pattern in the data. However, these two variables, age and criticality variables, will be helping. But again, when you go to an industry to solve a problem, this is the reality that only 2 to 5 variables will be very important. In some cases, just one. In some cases, you will have to just be dependent on the dependent variable only, and the other variables will be just mix spectators. You won't be able to remove them. You won't be able to, even if you include them, they won't give you any positive result itself. But you can't remove them because your business doesn't want them to remove. They want their, even if they contribute to 1% of the influence, they want them to be there. Okay. But you know that statistically it won't matter. But again, you'll have to keep them because of the business. So this is the reality of the industry, that only 1 to 5 variable. And even when I'm saying 5, that's a lot. Honestly, that's a lot. I've never in my life, like I haven't found out a variable, a data which is like highly correlated with my dependent variable, and the count of that variable is more than 3, honestly. So when I'm saying that these two, and that too with 38 and 28% correlation, it's still okay. It's not very bad in terms of industry experience, and it's not, obviously it's not very good from a machine learning's perspective. Okay. But that's the reality. Okay. So this is a very big reality check, and you can say this directly to an interviewer, and he or she will definitely understand what you're saying. Okay. That this is the reality. The data was really bad. We had to do feature engineering. Then you can talk about a lot of things. We had to do feature engineering. We had to do a lot of manipulation in the data. We had to remove this, remove that. We had to increase the volume of the data, blah, blah, blah. Everything will be, everything is a viable solution to improve your machine learning model. But again, you have to say that whatever data we had, we wanted to test it, even though we found out that the correlation was just below 40% and 30% in 2 of the columns, and the rest of the columns were not at all good. And when I'm saying that these are the best variables statistically that I have found, imagine what we would have done with the patient information that they provided, that they smoke 2 cigarettes a day or 4 glasses of wine every day and things like that. They were having lesser correlation with my dependent variable when I tested it. Okay. So that's why I've removed it. The minimum that we are seeing here is minus 0.02 as your urological. So again, it says a lot of thing about urological as well. Okay, so now we have replaced, imagine, remember, we have replaced the values, okay, the outliers in the urological data with median, and then also it is not giving us good correlation. That means if we replace, instead of replacing those value, we can do a sanity check again. If we remove those values, if we remove those rows from the data and then test it, it might or might not increase. That's your job to do. Again, you can do it. So just check whether that information that we have provided in the data, by replacing those outliers with median value, are making a positive contribution towards your machine learning model or not. Okay, cool. So I'll just write it down. Test the correlation after removing the rows with outliers present in urological. Okay.
Rahul, one thing.
Yeah.
So for the independent and dependent variable, we should have strong relationship, right?
Yes. For independent and dependent, you should have strong relationship. For two dependent variables, if you have strong relationship, then you need to drop one of them.
Correct. And if we have two strong independent variables, we can use the ones.
Yeah. You need to drop one of them. But again, if somebody asks this question, then answer in a diplomatic way, and because that's the reality. You don't drop it directly. You check it with your stakeholder or client and say that they both contribute for the same thing. Okay, they mean the same thing, and they and every time when you go into the industry as well, it will be very helpful for you, that they don't understand a lot of statistical concepts, but they do understand correlation, and that's a big advantage for us data scientists, that basically we can talk about correlation, they will understand what is correlation. Okay, and when you say that these two variables are very highly correlated, and that means that it will give a double contribution towards my predictors. Okay, they will understand that you can drop one of them, and then with the business context, they will understand, they will decide whether column 1 is more important for them or column 2 is more important for them. Okay, in some cases they'll ask you to find a solution to keep them both, and basically won't be able to do anything. You'll have to keep them both. Okay, or maybe take an average of both the column and encrypt the data and take an average of both the column and basically ruin your data, kind of something like that also happens sometimes. But in most cases they will decide that which variable is more important for them, and they'll ask you to keep it. Okay.
Okay. And if they ask to keep both, then in that case we can also apply regularization, correct?
You can apply regularization, you can apply an average method, you can apply a lot of things, but again, it will again affect the originality of the data, that we have seen that how it gets affected, and then obviously it will affect the correlation of the data with the dependent and independent variable as well.
Okay.
Cool. So again, going to check like histogram of the data. So this is again, it's basically your now that EDA part, cleaning part and EDA part is done. We are just checking the sanity of the data, like how it is behaving, like compared to age and lung, bone and skin. It's, there's no.
Like I missed 2 minutes, like due to my internet. Can you explain what you after the
After the correlation?
Yeah.
Okay. Rupesh, do you want to explain?
Yes, actually, in our data set, when we have a strong relationship between our input and a dependent variable, that then that is the good scenario. But on the other hand, we have multiple strong independent variables. In that case, we have to take either of them, and but it again depends upon the business need whether they want to keep those columns or not. If they agree that they want to keep those columns, then we need to do the regularization or average of those two columns, the correlation effect. And if they want that we don't need a particular column, then we can drop that column and keep the only single column. That will be the need. Okay.
Cool. Any doubts?
No, no.
Okay, good. So this is histogram. It's up to you if you want to plot it. If you don't, I just want to look at the get the feel of the data, like compared to one column with the other. So age compared to lung, and bone compared to skin, and things like that. So when I'm saying that it is a histogram, it's basically trying to like see. I'm trying to see the pattern in the data. So age is basically sometimes it's going above 100, and lung is going sometimes above 100. And again, operation criteria, sorry, heart condition is also sometimes going 100. In some cases it's going above 200. Okay, so just wanted to check that, do a sanity check with this, that it is not going to a very extreme value. Okay, and that's it. So in this case, in urological, there's just one histogram that says that it goes to a very extreme value, 400. But yeah, it can be a case because right now it's varying between 200 to 400, but we have handled all the outliers, so that should be fine. Okay, just for a sanity check. If you want to do a separate pair plot, okay, just to do another sanity check to see that how the pattern of the data is falling. Okay, so you can do that as well. You can just put multiple columns and do a pair plot as well. Okay, does not say a lot about the data, but just to give you a feel and sanity of the data, that it is not following an irregular pattern even after handling the outliers and everything. Okay, now for the insights, you can say that relation of the age with the critical patients, like you can say whether your age, the average age and the median 75 that we've got is very close to each other. Okay, and you can say that the age range is falling between 64 to 85. That's the exact number. Okay, and that's one of the insight that you can give to your client, that the information that you have provided, the age range starts from 64 and goes up to 85. Because
Rahul, one question.
and-
Sorry to interrupt.
yeah, sorry.
Regarding the pair plot, can you go above?
Yep.
Like here we don't have any pattern or don't have any relation between these two independent variables. So this
Yeah.
is fine, correct?
Yeah, this is fine. So basically, if it is following a same pattern, then that's a problem. Then there's a problem with
Correlation will be there, I guess, in
the
that case.
correlation that we have interpreted. Okay.
Strong
So that's-
correlation, correct?
Yeah.
Okay, yeah.
Okay. Now again, if you want to check, if you want to do a group by on region and check the patient count, okay, you can do that. So as you can see in the data, initially there were a lot of region which were there. Okay. Rio de Janeiro, Sao Paulo, Manaus, Salvador. These regions were there. And basically, if you want to tell your stakeholder that, say suppose you can see Brasilia, I think it's the capital of Brazil, maybe might be wrong. So Brasilia, it has the largest number of patients.
Yeah, it is the capital of Brazil only. Brazil.
Okay, cool. Yeah, so Brasilia has the largest number of patients, which is basically a normal scenario, because in capital city a lot of people stay. Second could be Victoria, and then Rio de Janeiro. These three cities are large cities in Brazil, and maybe even
Sao Paulo is a financial capital.
okay. So in particular, maybe in this sample that I've collected, probably the Sao Paulo patients are lesser. So that could be a case. It's a random sample that I've taken. So yeah. I mean, obviously, you can say that say that to your client that obviously a larger number of patients lie in Brasilia and Victoria, and then Rio de Janeiro, Natal, Sao Paulo, and things like that. Okay. Again, if you want to check let how critical your patient are, Okay, so this is a vital information that you can give to your client as a part of insights of the data. So what I'm doing here is basically I'm doing a plot of a bar graph basically to check the count of patient ID. Okay, and I'm comparing the criticality with the operation. So when you see when the criticality is 0, okay, the number of patient that are favored in terms of operation are very high as well. If the criticality is 0, okay, you can see that this left hand side 0 is basically criticality, it comes first, and the right hand side 0 is basically operation, which comes second. Okay, so when you compare that, you can see that when level of criticality is 0, I mean very low, level 1, then the number of people who were denied operation, okay, not eligible for operation, okay, is high, more than 600. But when the criticality level is basically 1, and in case where they were allowed for operation is very low. Okay, now when you compare the criticality level 2, okay, to 2, then the number of patient denied for operation were like in somewhat medium range, and people who were allowed for operation are also somewhat medium range. So it's not varying a lot, it's fine. Now when you go to level 3 of criticality, so more critical patient, okay, the number of patients that were denied the operation are less, and the number of patients that were eligible for operation are very high. So that's the imbalance here that we're getting, and this data makes actual absolute sense right now, because if the patient is highly critical, they should get operation. Okay, if the patient is patient criticality level is low, they should be denied the operation. Okay, unnecessarily, there's no need for an operation. Does this make sense?
Yes, sir.
Yes, Rahul.
Cool. Now, if you want to get the number of patient ID with level of criticality, so that's there, level 1, level 2, level 3. So level 1, level 2, level 3. Okay, and basically what it says is exactly almost 33% in level 1, 33.6 and 33.4. So very much balance in terms of level of data, level of criticality of the data as well. Okay, in the patients. So this information is also can also be shared. This information is very vital for your understanding and for the understanding of your stakeholder as well. So always try these plots to show them. And uh, honest to God, management people, they love bar plots. They don't like multiple other different plots that you want to try in future, but they love bar plot, they love pie chart, and they love line chart. So my advice would be, even as a data scientist, you should stick to these 3, and maybe the stacked bar plot, these 4. Don't try anything else. It won't matter whatever you try. They'll understand only these 3-4 graphs anyway. I mean, my point is, don't waste your time, trying to, think out of the box in terms of plotting graph and, showing it to them. They understand these 3-4 graphs, and they would want to get maximum information out of it. That's the point. Okay, so coming to the last bit of today's lecture, data preparation. Okay. So what happened here is, like, we have taken the feature names, age, bone, blood, lung, skin, urological, heart, other, and criticality, and put it all together. Okay. In my X variable, so my X is independent and Y is operation. So the only dependent variable is Y, and all the others are independent variable. And now what I'm trying to do is, I am just simply doing a train test split. I'm not giving it a number. Whatever train test split gives me, you might be knowing whether it's 70-30, 75-25, 80-20. Can anyone tell me the answer? What's the train test split gives?
70% of the
70-30.
Yes.
70-30, or depend upon the scenario, like 60-40 also some people used to take.
Okay, but I mean, the default
By default, 70-30.
70-30.
default is 75-25, unfortunately.
Can you
What
go
is
to
it?
shift tab for that trend split?
Can you repeat one more time, like 65, you said something, so
525 is the default value.
Okay, 75-25.
Yes. You want to see something, Rupesh? Sorry.
If tab, it will show the default value, I guess. Yeah, can you plus?
In the train test split.
Yes, good plus.
Yep. It will be set to 25.
0.25, okay.
Cool.
Yeah, we can use a stratify also, no, if we require.
Yes, yeah, we can use a number of things, but today I'll just keep it to basics, like just to set up a benchmark to a certain accuracy level, and then we will try to improve it. Okay. Okay, so this is done. This is done. We have done the train test splitting. Okay. Now we need to do scaling. So when we do scaling, there are multiple options that we can try. Okay. I've taken min max scaler. You can try with any other scaler as well.
Standard scalar.
Yes, standard scaler or a normalized scaler or regularization scaler as well. There are multiple scalars that you can try. Okay.
Rahul,
But
one question.
yeah.
Like here we are keeping the outlier in our data set, right?
Mhm.
So in that case, robust scaling is the best method, I guess.
We are not keeping outliers right now, Rupesh. Sorry. I mean, we have replaced those outliers with median, so there are no outliers present in the data, right? Any doubts?
Okay, yeah, we got it. Yeah, I thought we are keeping those. I missed that one.
No, we have replaced them, so it's there, but it is like in the median, replaced with median. Okay. So now, why we use scalar? Any point, I mean, before feeding our data with machine to a machine learning model, before feeding our data to a machine learning model, why do we use scalar? Can anyone tell me the answer?
Like standardize the features between the 0 to 1.
Yeah, I mean 0 to 1, -1 to 1, whatever it could be. But why do we need that? What's the need of a scaling?
As machine learning model should not be giving importance to any one of the category or a feature which has more scale as compared to the another one.
Exactly. So in simple terms, if I want to
Keep all
explain,
the values to keep all the values in the same scale, and it is also good for our linear models if we are doing scaling part.
so right now
So
you
the
can see,
computational time will also be less.
yes, that's correct. Yeah. So in simple terms, if I compare this data, so 1114 and 118, if you feed this data directly to your model, what will happen is it will give more importance to this number because it's a higher number, and my machine learning model obviously understands mathematics, but it will understand that this number is higher and this number is lower. So my long 1114 will be given more importance than 118 of skin. But do you think this should be the case? No, right? So it should all be scaled to a certain range so that uh, the higher number or lower number won't matter. It's all scaled to a certain range, and everything which is being scaled to a point where it's a very small range between 0 to 1, even though the number is higher in this case and lower in this case, it won't matter much, and it won't basically mislead our machine learning model. So that's why I use scalar. So once we have done the scaling, okay, we've done, as you can see, we have done the scaling on train and test both, okay, and we just need to import logistic regression from a scalar.linear model and store it in a object called logreg, and you fit the logreg model. Just call the logistic regression first from the library, then fit the logreg model with your x-train and y-train data. And once it's done, it will show that it's ready. And if you want to check the accuracy, I'm not going to discuss the predictions today because we are anyway going to go there in the next class. But for now, if you want to check that accuracy, what we have got, it's 65% for training and 68 for the test data. And it's kind of decent also because like when you see that the number of rows is 2500, and when you see that the correlation is this bad, you cannot expect more than 60-70% of accuracy, and that too from a basic model where we had not done anything.
We can apply a KNN, lazy learner, so that for get the better performance. So we can it will first train on first it will execute test set. After that it will execute the train set now. So we can for this we can apply KNN
KNN,
algorithm.
we will see multiple algorithms in the next class. Today we wanted to set up an expectation that whether the model is at all predicting positive or not, because the problem with this correlation was like we were getting like 20-30% or 40% correlation. So there would have been a case like where my model is predicting only 40% with 40% accuracy. Now it's like close to 68-70%. We can improve it by introducing new machine learning models or doing some feature engineering or whatever method we find is good enough for it. But for now, if our logistic regression is able to find a pattern in the data, and that too logistic regression is the very basic model, we can take the help of other algorithms to find the hidden patterns in the data and get the prediction much better as well. So those things we will discuss in next week's lecture. Okay. For now, I will stop here. Okay. With the expectation that you will do the inline homework. You will study the EDA part of this particular in the previous lecture, what we have studied. Okay. If you were not present in the previous class, obviously you can go through the recording. Okay. And you can get some information regarding EDA and insights as well.
Rahul, I have always a doubt in the correlation part. Remaining part I can able to see what is the main objective in that correlation part. Rupesh also told at the time, but I'm little bit confused. So can you explain once again?
Correlation
So,
part, what exactly is your doubt? I want to understand.
see, for example, if I am a stakeholder, so he can be he can visualize that. So he don't want to that. If you want to explain that, what is this graph? So say which one is correlated with which one, and what is the positive and negative impact, like that, scenario based. So I want in the scenario based in technical terminology.
In technical terminology, say, so if you want to understand how correlation works, so basically it is highly correlated to dependent variables. So suppose I'm trying to judge whether a person is eligible for operation or not. Okay. And I want to see that which variables will be highly influential, and you can do the same thing by a variable importance check as well. Okay. Will be very much highly influential towards my predictor variable, which is operation. So right now we can see that this orange and this yellow zone that is contributing 38 and 28% correlated, which means that if my operation is following one pattern, suppose it is following a linear pattern, that means my criticality is somewhat following somewhere a linear pattern, not exactly a linear pattern, but at least 30% of the time, 40% of the time, it is following linear pattern. Suppose it started to follow a linear pattern here, then it's starting varying. Then again, it started to follow a linear pattern here, then again, it started varying like that. Again, when you compare age with the operation part, again, if the operation is linear, my age started to probably in some places follow linear pattern, and somewhere it's again following itself some other pattern. Okay, so that's what happening technically if we talk about. Okay, because correlation, Pearson correlation check, basically the coefficient of Pearson correlation just describes that whether there's a linear dependency between the data or not. It can be a linear dependency between a dependent and independent variable, and there can be a linear dependency between two independent variables. Okay, if that linear dependency of two independent variables is very high, that means it is basically contributing towards the same goal, okay, of predicting predicting my operation basically right now in this case using the same information that is provided by my criticality and the age, if they both are highly correlated towards each other. So if my criticality here is right now 0.38, if I talk about age here, and if age right now and criticality are like negative 0.002, but if it is like 90% or 99%, that you can see if it is there and if it is falling in green zone, okay, then that means basically that criticality and age are very highly correlated towards each other. That generates the problem of multicollinearity in the data, and that says that you need to drop one of the columns so that they do not highly contribute towards your predictor variable, which essentially means that it is giving you the same information that you want, and pretty much you can get the same information to get your machine learning model learn from one variable rather than using the two variables. And the use of two variables does not make sense right now here.
Yeah, like if you want to drop a feature means then any advisor kind, for
Yeah,
example, like a business analyst or a what is it, business head.
business analyst won't give you any advice on this, honestly. Stakeholder will come into the picture and they will decide, because they know about the variables, right, that you're using in the data. They know about the variables and they understand correlation, not in this depth that I have explained, but they
Okay.
understand what is correlation. So you can always use correlation, line graphs, bar graphs, these things in your favor to explain that what you're doing in the data, what's happening here in the data, and what you're trying to achieve. Okay, always do that. Correlation they understand, and then you can say that there's a high correlation between these two, and basically these two are very influential factors in my prediction. And basically I want to drop one of them because they are creating a correlation between themselves which is not favorable for machine learning model.
Yeah, got it. So
Cool.
basically, product owner only coordinating with the client, and we will get the feedback from them through
You,
a user
you-
story
are
or
you
a
are you,
task.
are you working basically right now as a data scientist or data analyst?
No, I'm currently as a MLOps engineer
Okay, so
and DevOps
there's a
parallel.
slide. Okay, so there's a slight difference when you say that you work as a data scientist or data analyst with software developers or any other developer. So what happens is the communication is not direct in other IT sectors, but in case of where you are like data scientist, the communication is very direct and it comes directly to you. Okay, so you might one day will be interacting with the VP of the company. You might be interacting with the head of analytics. You might be interacting with head of sales department. One day there could be an interaction on a monthly basis or like quarterly basis, but you can interact directly. Okay, that's one thing. The other thing is your stakeholder is basically can be a product owner, can be a product manager, can be a shift supervisor, can be a sales manager as well. Okay, your product owner or your stakeholder basically. Okay, and with that person you can interact on a weekly basis. From a business analyst who's like working with you, you can interact with him on a daily basis. Your business analyst is your facilitator. Okay, you can go ahead and talk about data, talk about information that you want more, or you can go ahead and talk about data, or you want something from the data engineering team or things like that, directly to data engineering team or the sales or product manager as well. So
So here we are going to use Kanban or Agile came into the picture. So if you want to directly contact means which methodology they used to follow, data science field.
I have used Kanban is rarely used in the industry. Mostly it's agile because they want to work as a
Okay.
team and to complete things in sprint. But again, like if you are working as a research analyst anyways, your research won't be completed in 2 weeks, so they understand that. So that would be a problem. But yeah, the entire team wants to work in an agile format, so they usually work in agile. Yeah, I mean, this is one of the interview questions that they basically ask.
Actually, so for DevOps and MLOps, we always follow Kanban. Like daily, we used to get user story with the task, so we'll follow that and we do that.
We get stand-up calls daily. that's not the thing. We do stand-ups on a daily basis, but we set up a target for 2 weeks and then complete it within those 2 weeks sprint. That's all. Okay. Any other doubts, guys?
So here in correlation matrix, since two variables are like correlated, like they are contributing more towards y
Yes.
operation,
Yes.
but
Yes.
they are not correlated among themselves.
Yes.
So so since we need to do simple linear regression, we have to choose one. Correct?
Right now we can choose every variable because they are not correlated to each other. If they are correlated to each other, then you can do then you can check, then you can remove one of the column, drop one of the columns, even if you are doing simple linear equation, regression, or logistic regression, or any other machine learning algorithm, because the heart of every machine learning algorithm is a mathematical equation that is trying to learn something from those data points, right? And if you're repeating that information again, it's not going to help that machine learning algorithm anyway, because in any case, even if the model is basically a linear or non-linear, there's no point feeding the similar type of information as well.
Yeah, so I got that. So now, like, if we include these two variables, age and criticality, so it will become multiple linear regression in that sense.
Yeah, if it's a linear regression, model that you are trying to do, then yeah, obviously. But right now, you cannot do linear regression because the predictor variable operation is yes or no. So it's not a regression problem. It's a classification problem, right?
Okay. So here we need to choose any one, like after discussion, like
No.
among age. Hmm?
Yeah, if it is highly correlated, yeah, obviously you need to choose one.
But here they are not correlated.
Yeah, we are
Like
not here.
among them.
No need, because every variable is contributing towards a predictor.
Okay.
So Rahul,
Okay.
generally more than 0.5 is greater to be more correlated, correct? In
I
that
would
case,
say
we will.
0.7, Rupesh, not 0.5. 0.5 to 0.7 is still fine. If it's like 0.7, or in some cases more than 0.65, something like that. So yeah, at least 2/3 correlation is still fine. But if it is more than 2/3, then obviously it becomes a problem. So that's why.
Okay, okay. And one more thing, in the accuracy, to check the accuracy score for logistic regression, we generally use accuracy method, right? But
Yeah.
where here we have used like the attribute of our logistic regression,
Mhm.
correct? So both are the same term.
Yeah, logreg. If you use dot score, it comes from the statistical method, statistical package. So it's the same. Don't worry.
Accuracy score, and these are the same terms.
Yes, exactly.
Okay.
We'll discuss more about these things in the next class next week. Okay, don't worry.
Correct.
That is there. Okay, so at least I can assume that your basics are clear. You're good enough for designing a machine learning model, even with even when the data industrial data is pretty bad. Okay, but yeah, obviously your parameter tuning and things like that will come into picture next week. And my expectation that it would be that you have gone through this lecture, you have understood these things, and you are well prepared for the next bits. Because if you are lagging today, then obviously in this week, then you won't understand a thing next week. Okay.